Complex numbers. Multiply and divide complex numbers in trigonometric form. What are they? Complex numbers are a mixture of a real number and imaginary number. Why? They're applicable in electricity, specifically alternating current or AC electronics. Interesting fact: the opposite of melanism is albinism, which is an even rarer mutation that can occur in most animal species. Before we multiply or divide any complex numbers, let's take a look at some equations. Here we have the standard form and the trigonometric form and how to convert between the two. We also might need the unit circle, so take that out if you have one. Now let's take a look at the example we're going to discuss in today's video. Let's read the steps. Step 1, draw. Step 2, use the formulas. Step 3, follow order of operations. Let's read the question. Use the trigonometric forms to find the product and quotient of 2 square root of 3 minus 2i and negative 1 plus square root of 3i. We have the equations that you might need on the top right, which are z is equal to r times the quantity of cosine theta plus I sine theta, and r is equal to the square root of a squared plus b squared, and tangent theta is equal to b over a. Let's start the question. Let's start with 2 square root of 3 minus 2i. Let's also draw a coordinate grid with a real and imaginary axis. Since a, 2 square root of 3, is positive, and b, negative 2, is negative, our point will be in quadrant 4. Let's move 2 square root of 3 to the right, and 2 down. Now we know where the point is. We need to find the modulus, or r, and the argument, or theta. Let's start with the modulus. If you don't remember the formula, we have a right triangle, so we can use the Pythagorean theorem to solve for the hypotenuse or the modulus. Now let's substitute 2 square root of 3 for a and negative 2 for b. So now we have r is equal to the square root of the quantity of 2 square root of 3 squared plus negative 2 squared. Let's simplify. So now we have r is equal to the square root of 4 times 3 plus 4, and 4 times 3 is 12, and 12 plus 4 is 16, and the square root of 16 is 4. So r is equal to 4. Now let's find the argument. So let's substitute 2 square root of 3 for a and negative 2 for b. So now we have tangent theta sub 1 is equal to negative 2 divided by 2 square root of 3. Make sure that you use the values in the number and not the distances of the triangle, otherwise you might get it wrong, or you could add a few more steps to your problem. Let's simplify. So let's divide negative 2 by 2, which is negative 1 over 1. So now we have tan theta sub 1 is equal to negative 1 over 1 square root of 3. So now we need to rationalize the denominator, so we need to multiply by square root of 3 over square root of 3, and our result is negative square root of 3 over 3. So now we have tan theta sub 1 is equal to negative square root of 3 over 3. So let's take the tan inverse of both sides. So now we have theta sub 1 is equal to tan inverse of negative square root of 3 over 3. So if you use our unit circle or a calculator, we will get theta sub 1 is equal to negative pi over 6. Now let's graph our argument. We're still in the fourth quadrant, which is what we want because our point is in the fourth quadrant. Now sometimes when you're dealing with tangent and you use the calculator, it doesn't know which quadrant you want, so we have to check. Now that we have both r and theta, let's substitute 4 for r and negative pi over 6 for theta into z. So now we have z sub 1 is equal to 4 times the quantity of cosine of negative pi over 6 plus I sine of negative pi over 6. And that is the trigonometric form of 2 square root of 3 minus 2i. Now let's convert negative 1 plus square root of 3i into trigonometric form. Let's start with drawing a coordinate grid with a real and imaginary axis. Since a, negative 1, is negative, and b, square root of 3, is positive, our point will be in quadrant 2. Let's move 1 to the left and square root of 3 up. Now we know where the point is, we need to find the modulus, or r, and the argument, or theta. Let's start with the modulus. If you don't remember the formula, we have a right triangle, so we can use the Pythagorean theorem to solve for the hypotenuse or the modulus. Let's substitute negative 1 for a and square root of 3 for b. So now we have r is equal to the square root of negative 1 squared plus square root of 3 squared. Now let's simplify. So now we have r is equal to the square root of 1 plus 3. 1 plus 3 is 4, and the square root of 4 is 2. So r is equal to 2. Now we can find the argument. So let's substitute negative 1 for a and square root of 3 for b. So now we have tangent theta sub 3 is equal to square root of 3 over negative 1. Whoa! Why do we have theta sub 3 and not theta sub 2? Well, we're finding the angle inside the triangle, so we're going to have to do a few more steps afterwards to find theta sub 2. Remember to use the values in the number instead of the distances of the triangle, because you could get it wrong or you could add a few more steps. Now let's take the tan inverse of both sides. So now we have theta sub 3 is equal to tan inverse of negative square root of 3 over 1. If we use a unit circle, we might be able to get theta sub 2 with this. But if we use a calculator, we'll probably get negative pi over 3 for theta sub 3. Now let's graph our argument. This time our argument is in the fourth quadrant. What do we notice about the solid dark line and the dotted dark line? That angle is 180 degrees, or pi. So now we can find theta sub 2. So now we know theta sub 2 is equal to theta sub 3 plus pi. So let's substitute negative pi over 3 for theta sub 3. So now we have theta sub 2 is equal to negative pi over 3 plus pi, and the result of that is 2 pi over 3. Now that we know theta sub 2 and r, let's substitute 2 for r and 2 pi over 3 for theta into z. So now we have z sub 2 is equal to 2 times the quantity of cosine of 2 pi over 3 plus I sine of 2 pi over 3, and that is the trigonometric form of negative 1 plus the square root of 3i. Let's multiply z sub 1 and z sub 2. Let's look at the graph. Let's add z sub 1 and z sub 2 on the graph. So we have r sub 1 and theta sub 1, r sub 2 and theta sub 2. Now how do we multiply complex numbers like these? We multiply the moduli and subtract the arguments. So where do you think the product of z sub 1 and z sub 2 will be? To the left of the red line, in between the red and blue line, or to the right of the blue line? So let's find out by multiplying z sub 1 times z sub 2. We multiply the moduli, 4 times 2, and add the arguments, negative pi over 6 plus 2 pi over 3 in each parentheses. So now we have z sub 1 times z sub 2 is equal to 4 times 2 times the quantity of cosine of negative pi over 6 plus 2 pi over 3 plus I sine of negative pi over 6 plus 2 pi over 3. Let's simplify. Let's multiply the moduli. 4 times 2 is 8. We've also changed the second fraction in both parentheses to 4 pi over 6, so we will have a common denominator. Now let's add the fractions in both parentheses. Negative pi over 6 plus 4 pi over 6 is 3 pi over 6. Let's reduce the fraction, and 3 pi over 6 becomes pi over 2. So now we have z sub 1 times z sub 2 is equal to 8 times the quantity of cosine of pi over 2 plus I sine of pi over 2. Now this is where the unit circle comes in handy. Cosine of pi over 2 is 0, and sine of pi over 2 is 1. So now we have z sub 1 times z sub 2 is equal to 8 times the quantity of 0 plus I times 1. Let's simplify. So z sub 1 times z sub 2 is equal to 8i. Now let's take a look at the graph. Did you think the result would be between the red line and the blue line? Does this happen every time? And that is the product of our two complex numbers in trigonometric form. Now let's find the quotient of z sub 1 and z sub 2. Let's look at the graph. Let's add z sub 1 and z sub 2 on the graph. So we have r sub 1 and theta sub 1, r sub 2 and theta sub 2. Now how do we divide complex numbers like these? We divide the moduli and subtract the arguments. So where do you think the quotient of z sub 1 and z sub 2 will be? To the left of the red line, in between the red and blue line, or to the right of the blue line? So let's find out by dividing z sub 1 by z sub 2. So we divide the moduli, 4 divided by 2, and subtract the arguments, negative pi over 6 minus 2 pi over 3 in each parentheses. Let's simplify. Let's divide the moduli, 4 divided by 2 is 8. We've also changed the second fraction in both parentheses to 4 pi over 6, so we will have a common denominator. Let's subtract the two fractions in both parentheses. Negative pi over 6 minus 4 pi over 6 is 5 pi over 6 in both parentheses. So now we have z sub 1 divided by z sub 2 is equal to 2 times the quantity of cosine of negative 5 pi over 6 minus I sine of negative 5 pi over 6. Now we can use the unit circle, and cosine of negative 5 pi over 6 is negative square root of 3 over 2, and sine of negative 5 pi over 6 is negative 1 over 2. So now we have c sub 1 divided by c sub 2 is equal to 2 times the quantity of negative square root of 3 over 2 plus I times negative 1/2. Now let's combine the fractions inside the parentheses. So now we have c sub 1 over c sub 2 is equal to 2 times the quantity of square root of 3 minus I over 2. Let's distribute that too. So c sub 1 divided by c sub 2 is equal to negative square root of 3 minus I. Now let's take a look at the graph. Did you get it correct? Did you think it was going to be between the red line and the blue line? And that is the quotient of two complex numbers in trigonometric form. Now it is your turn. So go ahead and pause the video here so you can take your time to answer this question, and I'll show you the results in 3, 2, and 1. Here is c sub 1, c sub 2, the product of c sub 1 and c sub 2, and the quotient of c sub 1 and c sub 2. Did you get everything correct? Superb. If not, there's always tomorrow.